Algebra 1, Lesson 96, we are graphing quadratic functions. So we are going to be going through a step-by-step process in order to do this. And so we're going to be using the axis of symmetry, vertex, y-intercept, and later on some of the zeros of the function in order to graph these, along with some points on the axis of symmetry, so that we can have points on either side. So remember that our form for quadratic function is y equals ax squared plus bx plus c. In our axis of symmetry, we can find the x value, which means the vertical line that is the symmetry, using negative b over 2a. And we're going to use this form in order to find all of these different things. So let's start with an example. Y equals x squared plus 4x plus 5. So first we need to find the axis of symmetry, which means I'm going to be doing x equals negative b. Okay, so our a is 1, b is 4, and c is 5. So I'm going to be doing negative b, so negative 4 over 2a, which is 2 times 1, which means it simplifies to just negative 2. Meaning my axis of symmetry, that line where I have the same thing on the right and the left, is going to be at negative 2. We find the vertex by plugging that into our original equation to find the y-coordinate. So I'm going to be finding y is equal to x squared, which is negative 2, squared, plus 4 times negative 2 plus 5. So I simplify to get 4 minus 8 plus 5, which really just equals 1. Okay? And so that means my vertex is going to be at this x value of negative 2 and y is 1. The y-intercept is always my c value, so my y-intercept is at 0, 5. And we find a point where the line curves, and so we plug it in. Plug in 1 for x. It's just kind of arbitrary. If, though, the axis of symmetry lands on 1, you wouldn't want to plug in 1 because that will just find your vertex again. But let's just plug in 1 into this equation, and then we'll reflect it over the axis of symmetry. So we're going to say y is equal to 1 squared plus 4 times 1 plus 5. So we get y is equal to 1 plus 4 plus 5, which is really 10. So we have this point at 1, 10 that we will then reflect over the axis of symmetry. So let's plot all of these things on a coordinate grid. And I'll have to flip it back and forth from these pages, so just bear with me. So we first have this axis of symmetry at negative 2. Negative 2. Now I'm going to be using these small boxes as one unit, not the big pink ones, but the small blue ones, which means my axis of symmetry, and I'm just going to draw it with a little dotted line right here, is at negative 2. Not really part of the quadratic graph, but it helps us realize where is that axis of symmetry. And then we're saying that my vertex is at negative 2, 1, which means it's going to be right at this dot right here. Negative 2, 1 is my vertex. That's where it goes from decreasing to increasing. And then we look at my y-intercept, which is always c. Whoop, I flipped to the wrong one. So we have it at 0, 5, meaning we're going to be up here at 0, 5. And then we found this other point. We plugged in 1 and got 10, meaning we're going to be up here. And then we flip that across my my axis of symmetry, which means I need to stay at the same y level, but I say, okay, this dot at 110 is 3 units away from my axis of symmetry. So staying on the same y value, I go 3 units away in the other direction, meaning I end up right here, because it's exactly opposite, okay, of that axis of symmetry on the other side. I flip it across, which means I now have enough points to actually say my curve is going to be like this. Okay? Remember, parabolas don't end up as a V, they end up as a curve, so make sure that your quadratics curve. Let's try another one. Y equals x squared plus 5x plus 6, which means my axis of symmetry is at x equals negative 5 over 2 times 1, which means I have it at negative 5 over 2. I'm going to plug that in to the vertex using the axis. So I'm going to say y is equal to negative 5 over 2 squared plus 5 times negative 5 over 2 plus 6. Now, for this, you can definitely use those common denominators and do this. We really also can, if you are allowed by your teacher, you can plug it into your calculator as well by saying negative 2.5 squared plus 5 times negative 2.5 and then plus 6, which means, let's see, oh, I didn't plug it into my calculator correctly. Let's try that again. We end up with our y value being at a simple negative 1/4, which means that my vertex is going to be here at negative 5/2, comma, negative 1/4. Okay, y-intercept is going to be c, so we have 0, 6 as my y-intercept, and then we're going to plug in 1 for x, just like we did before. We say y equals 1 squared plus 5 times 1 plus 6. So we get y equals 1 plus 5 plus 6, which equals 12. So we have a point at 1, 12 that we will flip on that axis of symmetry. So let's try this again. So once again, we're going to put our axis of symmetry. This one's a little bit funky because it's in between a point, but we can go in between a box at negative 5/2 or negative 2.5, meaning I'm going to have this axis right in between here. Then I'm going to plot my vertex, which is at negative 2.5, comma, 0.25. And I'm going to erase a little bit so you can really see where I'm putting this. Putting at negative 2.5 and just down slightly, just a quarter of a box down. So it's not going to be on any lines here, but that is where my vertex is. I plot my y-intercept, which is 0, 6. So I'm going to be right here. I'm going to plot my value of 1, which is at 12. And then I'm going to flip that over the x-axis, which means I'm going to stay at that level of y equals 12, but I'm going to be 3.5 boxes away on the other side of this. So I'm going to be a half, 1, 2, and 3, meaning I'm going to be right here on that axis of symmetry, right at negative 6, 12. Okay? So, meaning I now have enough points to show that my curve goes something like this. And we always put arrows at the end of our parabolas because it goes on forever. Okay? All right, so here's another one that we can try. And I'm just going to show you a couple more here, and you can try some of these on your own. Okay? Let's see one that doesn't have a b value in what we do. So in this case, we have an a value of 5, b is 0 because we don't have an x, a full x value, and c is 4. Meaning that we can easily find our y-intercept, that is 0, 4. And our vertex comes from our axis, so we do negative b over 2a, negative 0 over 2 times 5, which means I get 0 divided by 5, which is just 0. So we plug that into my equation just like normal to say y equals 5 times 0 squared plus 4, which is really, once again, just 4. So I have my vertex at the same point as my y-intercept is 0, 4. So I really do need this extra point quite a bit. So I'm going to plug in 1 here. Okay, I might even plug in a second one if I don't have enough points to really see where it is. But I'm going to plug in 1. I have 5 times 1 squared plus 4. Remember, I square that 1 first, so I get y equals 5 plus 4, or 9. Let's see if we have enough points with this, and we'll flip that point over the x-axis at 1, 9 in order to see this. All right, so we have our vertex at 0, 4, all right, and then we have my point at 1, 9, and I'm going to flip that over the axis, which is really just my y-axis in this case, which means I'm going to be right here, 1 unit away from that axis on the same level. And I do have enough. Technically, 3 is enough. Normally, we want a little bit more. So we could plug in 2 here and say y equals 5 times 2 squared plus 4, which is 5 times 4 plus 4, or 24, which means that I could go up at 2, up 24, so 5, 10, 15, 20, There we go, right up here at 224, and flip that across the y-axis right here. And I have this really skinny little parabola here. Okay, all right. So we can definitely deal with something not having a b value. Okay, and here's another example like that. All right, now remember that we can also have zeros of a quadratic function, meaning this is where it crosses the x-axis. Not all parabolas have x-intercepts, but we can have them, and they're definitely useful. We can use a graphing calculator to find the zeros of the function, or we can actually use our skills of factoring in order to find them, because if we're finding something that crosses the y or the x-axis, that means that y is 0. We can factor this to find what x would equal by saying this is x minus 3 times x minus 3. And so if two things multiply to be 0, then this must be 0 or this must be 0. So x, in this case, we just have one x-intercept at 3. Oftentimes there will be 2, or sometimes there won't be any. So you can try that with these, factor them, and I'll show you one more. If we have 0 is equal to x minus 5 times x plus 2, that means I can say, all right, this left side has to equal 0, this right side has to equal 0, so x could be 5 or x could be negative 2. All right, so you can try these with some of these other ones as well, and you can also practice it using your calculator to find those x-intercepts. All right, last part of this lesson here. In order to calculate the height of an object when it's thrown in the air, we use the formula h equals negative 16t squared plus vt plus s, where v is the velocity and s is the height. So find the height of a baseball when it's thrown in the air with a velocity of 50. So I'm going to start plugging this in. Our height is negative 16t squared plus 50t. Okay, and it's 4 feet above the ground, so that s is 4 feet above the ground. Okay, what time does it reach maximum height, meaning I want the vertex. So in this case, I need to find negative b, so negative 50 over 2a, 2 times negative 16. I would simplify that and plug it back in to find the height. All right, that's all we're doing, is finding the vertex even in these type of situations. Plug it in, simplify, and you can find your height. And same goes with this one as well. You can try that one on your own. Well, I hope this is helpful for your homework and for studying.